So, hello, Happy New Year, and welcome everyone to the 10th Coffee with EMBL. Can hardly believe this is the 10th event that we've carried out. For those of you here for the first time, welcome. For everyone else, welcome back. So we have a lot to talk about. I think it would be fair to say if we had had Coffee with EMBL in January last year, none of us have predicted the way the year 2020 unfolded. So there's certainly a lot of questions about how this year ahead is going to unfold, and the role of science and how it will affect our lives. I'm very pleased to say that we have got a great group of guest discussants and speakers who I'll introduce shortly. A major theme for today's discussion is the importance of basic research and all that implies for how we carry out research, how we communicate it, and how we persuade our political masters and funders of the importance of continuing to support us. Great to see just so many people taking part again. We've had over 200 registrants to participate in the meeting today. I can see we've already got well over 120 people online at the moment. I'm sure more will join. That includes more than 170 alumni who have registered from all over the world. It's also great to see such great diversity in our meeting with over 170 alumni and also over 40 current EMBL staff, or as I like to think, pre-pro alumni, and representation from really all around the world. So that's fantastic opportunity for us to have an inclusive transnational discussion. So today, our three featured guests are Maria Leptin, Kai Siemens, and Sigrid Reinsch. I'd like to just introduce each of them briefly before we start the discussion. Maria, can you introduce yourself, please?
Right. I'm Maria Leptin. I'm currently the EMBO director and have been since, I don't know what year, 2010. I'm a developmental biologist, and I have a lab hosted in the DB unit here at EMBL, but I'm still a professor. Well, I'm now a retired professor at the University of Cologne, where I also have a small lab. Developmental biology and innate immunity are my topics. Should I say any more, Angus? Is that sufficient?
No, we'll come back in just a second. That's great. And I say I first met Maria when I was a PhD student, and she used to work down the hall. So I can even say that I knew Maria before she was, well, I was going to say before she was famous, perhaps I should say before she was quite as famous as she is today.
I think infamous might be the that period.
I'm far too polite to say that today. Kai, I guess another person who needs no introduction, but still I'd like to invite you to introduce yourself.
I am Kai Siemens. I came to EMBL very early in 1975 from Helsinki. I'm from Finland. And saw the growth, helped to build up the lab. And then after 25 years there, I moved to Dresden to start a new Max Planck Institute. It was really an EMBL in the East. The Max Planck hated that, so I could never say it. It was a Max Planck Institute, yes, for molecular cell biology and genetics. And now I have moved, acquired, and started a company. It's called Lipotype lipid analysis. It's a continuation of the work we do, but we are a global company. We export our services all over the world.
Fantastic. I'm sure we'll come back to that. It's not the usual way people approach retirement by starting a company, but I'm sure we'll come back to discuss that. And so our third guest today from the US is Sigrid Reinsch. Sigrid, could you introduce yourself, please?
Hi. Yes, I was at EMBL from 1992 to 1998 as a postdoc in Eric Karsenti's lab, so right down the hall from Kai. From there, I took a job at NASA. And so I've been at NASA since 1998, which is really different from EMBL. It was quite a culture shock. And I have been a PI. I've worked on a lot of different projects. Funding is an interesting topic that we will get into later, but I'm now currently the director, the director of education and outreach for NASA's space biology program at NASA Ames Research Center.
That's fantastic, and we really appreciate you taking the time to come and join us here. And I'm sure everyone's interested to find out more about the transition into NASA. So I was going to say watch this space, but it's such a bad joke that I'll just swiftly move on back to Maria and say, Maria, again, we're honored to have you here. For someone such as yourself who's had such an important role in European science, and I know is passionate about the value of basic research, which is something that I think interests everybody in this audience here today. I'd just like to invite you to perhaps share with us some thoughts on your career as director of EMBO and where you see that heading in the future. And one of the questions I really wanted to ask everyone, all of the speakers and participants is, are you optimistic about the future?
Okay. Well, so first of all, yes. In response to your last question, yes, I'm optimistic about the future. I don't know why. I don't know whether that is a personality trait or based on reason, but it's, the world has seen so many challenges and during my lifetime. And I've heard so much pessimism, but we've always come through. Touch wood. I mean, we only just scraped the corner in the recent past in the US. I say we because it has such huge implications. It is scary to see how things can go wrong. But we've also seen fantastic solutions. And of course, COVID is the obvious one. And that brings me right to basic science. I'm happy to talk more about EMBO and my role there, but I think let's keep it general for the moment. So the ERC has put out a list of their projects that are related to COVID, to show how basic science has tackled this problem. And because the ERC funds basic science, we at EMBO have asked all our members and junior and young investigators to hear what they've done. And what I found amazing is not the ones who have been working either on viruses, virus assembly, whatever you name it, or, any of the molecular biology of viral infections, but how so many others who worked on other fields have been able to switch and contribute. And that, I think, it's because all these people, so lots of people who've never worked in the field before have been able to contribute. It's because they are well-funded and highly trained basic researchers who have the capacity to deal with problems like that. And I think this illustrates the value of basic research so much better than anything else. Had we had 30% of the research community been working on something else, let's say dementia or so, focused and goal-driven, this might not have been possible. As it was, a challenge arises. The people, the basic scientists, were able to get up and deal with it. And we've seen how they do.
So sorry, just to take on that point, I can't agree with you more. I couldn't agree with you more about this. But one of the surprises or concerns for me that I'd really like your perspective on is someone who has, I expect, had to deal with a lot of the politicians who are responsible for providing the funds and communication with the public. It seems so obvious that we need a broad base of expertise because the future is uncertain. As I said in the introduction, this time 1 year ago, I honestly don't think almost anyone in this audience, unless there's someone here again from Wuhan as we had before, but almost nobody else outside China would have really expected what happened in Europe, India, North America as 2020 unfolded. And that unpredictability about the future, which benefits so much from having broad-based expertise, it seems so self-evident. Why do we have to explain it so many times?
Why do we have to explain it? Because it's self-evident to us. We know how we can switch. We know what a good scientific training and good critical scientific thinking does. We know that. We know that. But how can the man in the street or the politician in parliament know that? They can't. It's our duty to keep telling them and to keep explaining patiently. And I really think that is sometimes people like to rant. I mean, this is something I've learned in my interactions with, I mean, just like Ian who's here, both he and I have to deal with representatives from our member states who fund us. They are willing to listen, and we can explain to them, and we must. And, I actually think the Wellcome Trust in the UK has made it part of their good grants, has made it a duty to the scientists to engage more in public communication. We have to do it. We have a duty. We can't expect them to know. We can't.
So was that a major part of your role in EMBO to find better ways of communicating?
Well, we're preparing some projects. So you see, communication with a citizen in the country usually has to be done in the national language. EMBO is international. We do not have good national representation. We're really working at the European level, and it's not so easy there. What we do, we're doing what I think, preparing an interesting project on training journalists or embedding journalists more into scientific environments for them to learn, to get contacts. Often they have to respond fast. They don't normally have time to do a lot of in-depth research. And so we want to do a program where they establish a lot of contacts so that when communication is needed, they have the contacts, and also to let them see how science is done, both in biology as well as in other disciplines.
I noticed in the chat a really good point that was made by Uli, which you may have seen, where he's just posing the question, what if this COVID pandemic had happened previously, before PCR had been invented, or before some of the other fruits of basic research? PCR was not invented with the perspective of providing a technology for, testing the population around the world for viruses. And that's true of so many fundamental discoveries in science that then find applications, maybe not immediately, maybe it's certainly not necessarily the original cause. There have been many examples of this, and I think that's a really exciting and important message to try to repeat. I'm just searching for an understanding of why it is in our world where there's more communication possible than ever before, via social media platforms, for example. How do we communicate better? Because it's very easy to feel that social media and the modern ease of communication is actually doing the opposite. It's creating echo chambers for people to spread misinformation.
Can I just add one thing to that? I agree. Of course, it wouldn't have happened. There was also less travel then, so it might have spread less quickly. The amount of exchange people between different countries now is vastly more than in the 70s. But the communication now has actually been good, because one of the things that happened very early on is that data about the phenotypes, about the symptoms, were shared among doctors incredibly rapidly, incredibly fast. The whole medical profession worked together across the world and were able to communicate with each other and talk about ways of dealing with the disease that would also not have been possible in the 70s. So it's really our current culture and social situation may have made the disease spread faster and worse than it would have then, but all sorts of technology and knowledge have helped to contain it and deal with it much faster than we could have.
Yeah, I agree. I think that's another fantastically important message that we have to keep repeating, that an EMBL must be one of the best forums or organizations to spread that message of the benefits of interaction and communication that breaks down borders and really helps us to build a broad base of knowledge that we can all benefit from. And I would like to shout out, I hope, Peter, you can put the link here for people in the chat or elsewhere. But there's a very interesting article also about the role also from EMBL scientists in the background technology that was built upon to create these new classes of vaccines, such as the AstraZeneca vaccine. And Ricardo Cortese, who worked here in the same, and he was the person who recruited me to EMBL originally, and he moved from basic research also into the pharma industry and made fantastically important contributions. And some of those have gone all the way through to underpinning the rapid advances that became possible as we see today. And that's a theme that, I think we want to pick up also. So I think Noosh has just posted that link. If anyone would like to read about that, I think everyone at EMBL should be very proud of that contribution. It's another great example of how uncertain the future is, and how, as Newton said, I think when you see further, it's by standing on the shoulders of giants. And so making broad shoulders is why we need good basic research, I would think. But
like putting,
yes, Maria, I'm sure you have better examples than that you could tell us about.
I think others should talk. There are tons of examples. I mean, PCR, the other one, CRISPR, which is not so relevant in this crisis situation, but will be important elsewhere. That was just pure curiosity-driven research, purely from many, many different sources, and nobody dealt with it. It's an immunity. It's even in these nasty bacteria and yogurts. Stuff that really was as unsexy and untrendy at the time they were working on it as anything. So there's endless examms.
So
can I jump in a little bit, Angus?
Sure, Sigrid, sure.
So I just wanted to talk a little bit about that connectivity and how important that is. And so one of the efforts that I have worked on for years is a project called GeneLab, which is basically a public database of omics data from space flight experiments, from biological experiments in space. And so we've had these analysis working groups. And one of the things that happened is that actually our analysis working groups, which we have in different topics, plants, animals, multi-omics, et cetera, one of them basically pivoted to looking at analyzing any COVID-19 data that they could get. And we formed an organization that's now a nonprofit called Covert. I put the link in the chat. But because we had already established these international working groups, it was and that were basically, focused on analyzing biological data. It was a very easy pivot to work on the disease. And NASA even, so a lot of the members are from NASA. And one of the things that we did was actually get NASA to donate their supercomputer for analysis of biological data on COVID. And so it was, it's been a really interesting partnership. One of our main partners is Chris Mason, who's at Weill Cornell, and so he has access to a lot of primary data from patients. And so that's been a great collaboration and a great way to pivot, and other things that we've done. I run a couple of, summer internship programs for high school students and for college students. And we were able to pivot both of those to virtual internships. And those are important because they're fully funded internships. So, rather than students sitting, who knows, going out and getting infected, we saved, 30 interns and a bunch of high school teachers income, gave them income over the summer last year, and we'll do it again this year. So that ability to pivot, and I really echo what Maria said, is that, scientists are, what we're used to doing is learning. So learning, I think a lot of scientists have been very interested, in learning about virology and the disease and, the whole immune effects. I mean, I've learned a lot in the last year. I had some basis in immunology and virology, but now I really know a lot more. And that's been very interesting for me personally, participating on the Covert team, and working with international teams on projects. So the Covert team, they came up with a one of the things that we did along with the omics analyses is coming up with a masking app. So basically an app that you can use on an iPad to determine whether people are actually wearing a mask properly. And so you could put it in, NASA's actually got it at NASA headquarters at the doorway. So you can, they can actually monitor the people coming in. So there's all, that I also echo Maria's, what she said about people being funded. So a lot of the scientists are funded. And so we were able to work from home, even though, those that are able to get into the lab, to be able to do that. And so I've been fully employed the whole time, and that's definitely a luxury and something for which I'm very, very grateful.
Thanks, Sigrid. I'd like to come back to that short because I think we've, in the biology community, have a lot to learn about how effectively NASA and space science, which is hugely expensive, but also hugely exciting, and how you can convey that sense of excitement and also remind people of by doing fantastically good engineering and solving problems and being inventive, you can also spin off technologies that end up having applications well beyond the original intention. Just Maria, if I could come back maybe to get your thoughts on how we translate the importance of this effectively. So one of the big problems that I think we all encounter in our lives in science is getting funding, and the potential for fashion and what's hot and trendy to overemphasize what committees decide they want to fund. Now, obviously, you've been heavily involved, Maria, and Kai, and many other people here as well, in committees that allocate funding or who choose programs, and they are pulled in many different directions. But how do we solve that problem of not over-emphasizing funding going to what's short-term trendy is sexy rather than, just really high-quality stuff where maybe there isn't a big application. Maybe it's not going to cure cancer tomorrow, but actually, maybe it will be instrumental to curing the next pandemic.
So I think that is really being done very well by most research funders, at least in Europe, and also in the US. NIH is supposed to be health, but buckets of basic science are being funded. NASA, for Christ's sake, they fund basic research. I really don't see much of a problem. The ERC, very explicit about it. The German research funding organization, Wellcome Trust, again, is supposed to be health, but, they fund people like Peter Lawrence looking at segment boundaries, hey? So, and fantastic work. I think we have very little complaint about that. What I really hate is when we, as scientists, whether we're writing grants or whether we're writing the abstracts, and we work on XYZ, let's say compartment boundaries, and then end up our abstract. This may, have implications in this or that part of curing cancer or Alzheimer's or the next virus disease. I really think we should be honest and not do that. So when my lab members write that, it goes straight out. Any paper I get where it says that in the last sentence, I asked, are you doing this for that reason? And be honest about it. Otherwise, it goes out. We have to stop doing that. We have to be honest about that. How can we expect funders to fund basic science if we pretend we're doing our basic science in order to cure a disease?
If I could push back just a little bit, and I'd like to also bring it
on that one.
So Kai, please come in.
Yeah. And I think this is one of so basic science means that we are trying to get the things right. And we know it may be right today, 5 years later, new experiments come and they change. And we have to get that into the minds of the people, that there is no truth in our doings, which is absolute. It changes and gets better. So we are building and building and building. We're the only ones that are building something which is always improving. And that, I think, is one of the most important facts of being basic researcher. But that also means that when we see faking, fake science, all that, that how do we treat whistleblowers? It's still a complete disaster. I mean, the institutions do not, I mean, Germany has a pretty good system, but most systems, I take Finland. I've been through it. I know how bad it works. Look at Karolinska, Sweden, where they are distributing the Nobel Prizes in medicine. And they had this real faker that they got faked by. I mean, so I think it's one thing that we really have to be sincere about trying to protect the things we do. And I don't think we even put that enough into our training of scientists. That, you know, you embellish a little, you take away one result and all that, and make it into a clear thing that this is not allowed. So I say that basic science is extremely important, but there are also many problems that we as scientists have to take care of in our own circles. But we cannot be arrogant and think, I mean, I think there's no problem to understand that most people don't understand why basic science is important, because we are not so good at really communicating what we are doing in such a way that the people understand. And if you look at the science teaching in schools, I mean, the programs are pretty rotten. I mean, they could be much, much better. And all that is important to change this world. And especially when we think about what's coming. COVID was nothing compared to the global crisis, the climate, all that. We have to innovate. We are damned to innovation. And I think that people have to understand. We come up with new things. There are always side effects. And then we have to correct them, solve them, go on and on. And now we have side effects which are enormous because we just ruin the basis of all we have. And we have to make that clear. So people have now been practicing. It's a good practice, this COVID thing. I find it very important because the next step will be much more difficult. And that we could mobilize so much that we got a vaccine so fast, incredible.
Yeah, I mean, there's a well-known saying that necessity is the mother of invention. And actually, the COVID crisis was a great example of some of the best of inventiveness when pushed to act quickly and produce high-quality output. And so where would we have been without the science community? But just to come back, I mean, I'm delighted that you are so optimistic about the situation. And I share many of your comments. The pushback I would say is I have had a small amount, but limited, but still some interaction with media, both local and national media, through newspapers, television, and so forth. And I have to say, at that level, it's really difficult to talk about basic science because that's not how I see it presented on television. I see it or through the media and through the small number of personal interactions. It's always, but what's the point of that? When are you going to deliver a cure? When are you going to do something applied or useful? And I almost worry about the words we use. I mean, calling things basic research, somehow, I think there's a tendency for people, at least in the UK, to think that this is ivory tower, not important stuff, when actually it's vitally important. So I wonder if you could comment on, have you had a better experience with the media?
You know what?
Okay.
I just want to say one thing, and that I think is dangerous. You're again saying it's vitally important because we can then deal with the next COVID case or I don't know, chemical contagion that causes neuro symptoms or whatever. True. But please, let's also not forget that there is an element of ivory tower. Research is a cultural activity as much as it happens to have the side effect of helping us cure COVID. And if we forget that, then we forget that there are many other cultural research activities in history, in the classics, in the social sciences, in the humanities. And I really think we have to remember that too. We should protect that and not say all our basic research is so great because eventually it provides the shoulders for the giant to stand on. It's also good if it's interesting. Of course, not everything basic is, there's some bloody boring research. And just because it's basic is an excuse to do boring research. But I think we have to, I care a lot that cultural aspect, the intellectual aspect is also remembered. It's just
I would agree with that.
And let me add one thing. For some strange reason, the public doesn't tune into that in biology. They do in a field about which they understand even less, namely nuclear physics. The Higgs boson, they all think that's bloody cool. And the fact that CERN gets 10 times as much money, or 100 times as much money as EMBL, they don't mind that at all. That's fine. That's cool. So there is an appreciation in principle for the beauty of scientific discovery, but for some reason, it's not about our stuff. Anyway.
Yeah, I agree. And what I just want to say is I think you're absolutely right. And I think the public, as you said, with CERN or with NASA, are prepared to see large amounts of their taxpayers' money devoted, but we have to at least convey the sense that it's important, that it's really important. And so to try to be elite, but not elitist, that's how I would say, because the idea that it's elitist and it's just people doing things for their own interests that are not really fundamental and important. Could I bring for a quick comment, Prakash?
Yeah, actually, I want to make one generalized comment that is in lieu of Maria and I, that there should be, and I personally feel that, as far as the biological research is concerned, and this COVID era, everybody has focused their research to the COVID. Whether a person has previously worked with the immunology or virology, they are now jumping on there with their own concept on the COVID-19 solution. So, but in my opinion, there should be a kind of balance between the basic research and applied research, because basic research, though very important, is a building block for the applied research. So, there should be kind of, a balanced concoction of the support towards how much we should support the basic science and how much we should support the applied science, and how much should go to the translational side, because the current time is the time for the translational research. We all know the basic research have already been done in the last 3-4 decades or whatever. So now we have to build on using the building block of the basic science. So I think the translational research should be given the more priority nowadays, whether it is interdisciplinary, and it should be interdisciplinary. That's what I wanted to make comment.
Okay, and that's certainly something we're going to come back to in a few moments with Kai also. I just wanted to follow up on this theme of how we do the best job possible of explaining why what we're doing is exciting, important to enthuse the next generation of people growing up to take an interest and want to become scientists. And Sigrid, I hope that you could perhaps share some perspective on, well, first of all, how are things in the US? Are you all feeling more optimistic about the future for science now you've had a change of leadership? And could you maybe share with us your experience of moving from EMBL biology into NASA and space?
Yes, well, that's a huge, I can go on all night long, all day long about that. But so we all are.
I don't know if you have frozen. To me, you have frozen. I don't know if we can fix that.
Can you hear me?
Dita, can we bring Sigrid back?
We can hear her.
I think she was particularly.
I can see everybody. So can you hear me all right?
Yes, we can.
Okay. All right. So I'll just keep going, and hopefully my internet will get up to speed and my face will come back. But so yes, we are all breathing a huge sigh of relief. You've all heard in the news that a lot of the federal agencies had huge cuts and huge changes. That Trump installed a lot of people at leadership positions in those agencies, in particular at the CDC, that really undercut the science at those agencies. That didn't happen at NASA, fortunately. And so our leadership, basically stayed intact, and most of our structure and our funding, et cetera. So over the past 4 years, that has not been a problem, but over the course of my career at NASA, it was a huge problem. So when I came to NASA, and I was hired based on my basic research from EMBL. Once I got to NASA wasn't interested in that research, and any other agency that I applied to wasn't interested in funding me at NASA, because they assumed that I was, why should you do that research, that basic research at NASA? And so it's been a struggle my whole career, and I've had to, I've switched my focus of study. I've worked on algae and wastewater. I've worked on, bacterial cellulosomes. I've gone into, I've worked on, I had worked on frogs in Eric's lab for many years, and then Mark Kirshner's lab before that. And so I now work on invertebrates. I work on tardigrades and look at radiation damage, and I don't have a big lab. However, I do participate in a lot of very interesting scientific programs and research, and basically the whole idea of basic research informing, that getting those translational benefits from that is really critical at NASA. And that's one of the things that we actually spent a lot of time convincing the people up high that provide the funding. That's really critical. And so working on model organisms is a very important thing for space science, and actually for human health, and potentially for astronauts, being able to have manned missions to Mars and the moon and all of that. And so it's critical to actually be able to explain the importance of basic research, even within our workplace on a daily basis. So why do we do this? Why is it important to have experiments that you can repeat, and that you could get statistical significance out of when you're doing them in space, and it costs $1 bazillion to be able to even do the experiment. And so that's one of the things that I have focused on throughout my whole career, is actually making sure that that the science that actually gets flown, that comes out of the institute where I work, is actually good science. And I asked to be put on, scientific control boards to actually evaluate the science and make sure that the experiments are going to work. And I don't have ultimate control over that. And so that is something which is really important. So to your other point about how do we, communicating to the people who fund us, that's one thing. Communicating to the general public is another. And NASA, they always want, they always want to publicize everything and make it gee whiz and this is fun. And so you kind of have to be able to frame your research in that way. And I spent a lot of time actually going to just science fairs and communicating with the public and figuring, and just actually having that exposure with people coming up and asking questions, and how does this work? And, even explaining to colleagues, like carpooling to sites, basic biology concepts is just, something that I have always done. I've always done it with my kids. I've always done it with their friends, so getting in that, just having that as a practice, communicating with your family, communicating with the general public at every opportunity is one way to make sure that we communicate the difficulties, we communicate the problems with funding, we communicate, the changes in science, the fact that it's, one day it's the truth, and the next day it's, we've discovered something new, which is now the new truth. And making sure that we always frame it in the fact that it's, what is a hypothesis, and that what you're doing is always testing a hypothesis, and getting that concept across at the very young levels is really, really critical. So one of the programs that I run is actually, is called Gene Lab for High Schools. And so we bring in 15 high school students and as many teachers as we can fund. And we train them in bioinformatics and how to actually, so it's in this 4-week intensive program, we teach them how to analyze data, how to read scientific literature, how to develop a hypothesis based on the data that they analyze, and to propose an experiment that could test it. So getting that, at a very young age, training students to be able to do that is phenomenal. So I think, training the public to be able, at very young age to understand science, understand biology, understand biological concepts, and especially how to test ideas is really critical.
Yeah, I think we have a huge amount to learn that you can help and as with how we can better excite the public about basic biological research. I think one thing, if you could do me a favor, which is one small thing, is when I was at primary school, and the Americans first landed on the moon, I wrote to NASA as a 9-year-old kid, and even as a crazy sort of 9-year-old child from Scotland, the American NASA sent me a package with photographs and information about the space program. And it's hard to underestimate how much that enthused and excited me about science and exploring. And so I just hope that, again, you can convey just how much of an impact you can make by reaching out and finding ways to, engage with people, because it would have been so easy for them to have torn up the letter or think this isn't someone whose parents can vote in my constituency, but they were still doing this. So I think we'd love to hear lessons from everyone in this forum from around the world as to how to we can better excite the public. I think politicians struggle with this idea of uncertainty because they want absolute answers to things which we don't always have. But Kai, can you maybe explain to us as one of the fathers of cell biology in the world, and never mind in Europe, how do we make cell biology sexy and encourage young people to want to do it? Could you have to unmute, Kai?
No, we're good. Okay. Yeah, that's an interesting question. And when we moved to Dresden, the challenge was that we moved to a place where there was no molecular life sciences at all. The technical university was completely classical. So, and that was really the challenge. We wanted to go there and see if we can change things. So we really had to do a lot to connect. So we started a prize. They have a very famous art academy there, and we had a prize for one of the master students. It was a competition. Would get 5,000 euros, and then they had to stay 2 months now and then to make in the lab in one of the groups, and the group leader who then decided to pair to the prize winner and the group leader, and then they made their art, piece of art in our institute, and they, for instance, let's take this one. So there was one of the prizes was the face of a bust of Max Planck is in every Max Planck Institute. So this guy worked with Suzanne Eaton, sadly not here anymore, and made wax that a head out of the wax that Drosophila loves, and then he put into the bust of Max Planck into this transparent box and made a video where the flies were eating up Max Planck. It took a week. And it was a fantastic video. And we, of course, got lots we got calls from Munich and saying, you can't do this, this is not good.
Oh, God, that's so startling.
And we had the press and all, we had lots of all those things. So we tried to reach out. And also important is that we open up the institute for groups from seniors to kids, small kids, and had people at the PhD students, anyone could help, but we had someone who took care of it all. So they came through and saw it all, and we had a program for them. And I think all that for a way that we were really, won't go through more, but it was an outreach program. And I think every science institute should have something like that, because then it spreads all over the world. And there is so much curiosity, also with all the people, children, of course, And if you have things there that you can show them in such a way that they get excited, that I think is important. So
I would be
something that we don't do enough, period.
Yeah, I agree. I think when we look at, sorry, Kai, when we see these examples with space or with particle physics, one of the summaries I think you could say is although they're complicated, they also convey a feeling of being at a frontier of discovery. And I think that idea of exploring at the frontier of discovery is something that does really excite people. With my own students, I like to remind them all the way from the undergraduates that even if they've done a relatively small experiment, that they can be the first person in the history of mankind to know that piece of knowledge, the first person in the entire existence of the world who knows that fact. And it may turn out in future to be more or less important, usually less important, but still that's an amazing feeling of being at that frontier. And that's one of the things. Keith, I'll bring you in just a second, but Maria, maybe you could also comment on how you would see the opportunity for conveying that excitement of the frontier of biology to research.
Yeah, it's wonderful, isn't it? I mean, lots of people are commenting here about what their institutions do and engaging with it. It's wonderful. It requires, I think it requires individual effort one-on-one. Teachers are taught at universities and high-level research universities, at least if I can speak from my experience. They're sort of the fifth wheel, and they're not given the attention they need. But I don't find that so surprising either. Although some of the teacher students in my lab have been fantastic. So I don't have a good solution, but I think the individual efforts that are being listed here in the chat are very admirable. And like I say, the Wellcome Trust insists that. And everybody, of course, rolls their eyes and thinks, oh, no, not that too. More paperwork, more additional. Why can't I just concentrate on my research? I don't know. I would be interested. For instance, do PIs here think it's a good idea if you get a good hefty grant to have as part of an obligation to engage in public outreach? I would like to know what the community thinks about that. With the Wellcome Trust, I was on the panel there for some time, as many as have been. They just had to accept it. And of course, you can get money for it. You don't have to do it all yourself, but it's your own inspiration that has to enter into these projects. So I'd like to see.
Yeah, so please put your comments for Maria in the chat and get feedback on this. Can I just bring in Keith, who has his hand up, wanted to make a comment? Keith,
I wanted to make a comment about enthusiasm, encouraging people to understand science, who are as old as I am. And when I was at EMBL 2004, my then boss joined me in a male voice choir, which had 100 singers. There were only 70 now. And they were curious about what was on at EMBL. But the whole of Rohrbach was the only prize in Heidelberg that voted against the EMBL expansions. My friends were asking me if they could have a tour of EMBL. So I arranged one with the visits section and arranged for food to be provided and everything. And we came up with husbands and wives. And there must have been 50, 60 of us there. And everybody there, all old fogies like me, or older fogies than me at the time, were thoroughly interested in what went on, asked loads and loads of questions, and would have gone on forever if they weren't told if they didn't stop, they wouldn't get any wine. And after that, we all went away. And at every choir practice thereafter for a week or so, they all came up to me and say how wonderful it was, how much they'd learned, and how impressed they were by it. And now Rohrbach's one of the communities that's most supportive of it. And that was just listening to a postdoc explaining something in a way that they could almost understand. You have to remember that most of us, scientists, start off at a level of understanding that you can't imagine. It's sort of 10 degrees Kelvin or something like that. And that worked wonderfully. I ended up having to pay for the food and drink myself. I was just visit people talking about that they didn't have a budget for it. Head of finance, I didn't think it obliged them. But it wasn't.
I think that's a good example. And I think we need to have more tagged often into throughout our institutes and really open up. And I think that goes back to my comment about us being a little bit humble about the fact that the people may not all be scientists, but they are ultimately, in one way, are the people who fund what we do and support it. That we are trying to be elite by doing the best science we can, but not be elitist in terms of thinking we are above our society. Sigrid, please come in.
Yeah, I just wanted to make a few comments. One is just that, so for NASA has a huge budget for science communication. And that is, they do have professional communicators that are involved in vetting what gets released to the public. So if I make a public appearance, if the news comes and talk to me, I have to have somebody from our PAO office, our public affairs office, actually monitor that. Anything that goes out for news really has to go through very specific channels. Generally, just speaking to the public, that's different. But we have, at NASA, we have, when things are going well, we have big public events where we invite the public to meet astronauts and to watch, to watch a launch or whatever, and tell them about the science. And we set up, we invite the scientists at NASA to have to put up a booth and describe their science to the public and to generate, things that, stickers and things like that you can come up with. And so every mission has a patch, and those are the stickers that you get from NASA is a NASA patch about every mission that goes up to the International Space Station. So basically, what's really important is actually having a bona fide communications plan, and I think, and one of the things that you asked about was, should funded research require that? Well, the NSF actually requires that in all of their grants. The National Science Foundation from the U.S., you actually have to include a communications plan in your proposal for research. NASA doesn't necessarily require that, but they do require that everything gets released to the public, and they don't require that it gets translated to, an 8th grade, knowledge level. But NASA does that to a great extent, anyways. One of the, so I think what's also critical is training young people how to actually communicate in that way. And so in the college program that I run, we train the students how to give professional presentations and how to, how to, and we make sure we give them opportunities to present at conferences, to have student poster composition, competitions, et cetera, to participate in those. And our students win. Our students win those competitions because we specifically train them in how to communicate their science at a very young age to be compelling.
Maria, yes, please.
So I agree, and young people nowadays are much better trained. And also, sorry, I think Thomas Vaccari said here, every PIs should be trained. Yes, they should be, but I think we have to not go overboard. The PIs who are highly funded are selected for a different talent, and not everybody has a talent to communicate. Yes, we should be trained. Ideally, we should be obliged to somehow communicate, but we have to keep in mind, not everybody is able to do it well, just like not everybody's able to teach it well. We have to take that into account. But I think it's okay to have others, to build teams, to get together, to delegate. But it has to be clear that it has to be there is an obligation. And it's, self-saving obligation. But we have to keep it. I don't think everybody should be made to really now do the communication themselves. There are people who just have much better ideas and have a much better relation. Sometimes scientists are very autistic. That's okay. Let them do their science and be autistic. Then somebody else has to do the translation. If they go out, it might just back.
Yeah, I agree with you, Maria. And I think that while it's great if it gets funding agencies, ask for people to think about this. We have to realize that it isn't maybe sufficient, necessary, but not sufficient, because otherwise there's a danger it becomes just another of those boxes you feel you have to put something in but don't really commit to. I think this community could actually communicate science effectively and can bring a lot of expertise to doing that. I mean, I have one question, especially for any structural biologists out there. So we talked about, the Higgs boson and how that generated so much national excitement. Obviously, sending rockets up, maybe if Elon Musk gets humans to Mars, it'll be a lot of excitement about that. But, very recently, I believe from the structural biology community, one of the great unsolved problems of generations, of certainly my lifetime, I believe was a massive breakthrough was made in computational approaches to predicting protein folding. And I don't think that has managed to penetrate. Maybe it's because everyone's preoccupied with the pandemic. I don't know. But this was, I think was, a sort of Higgs boson level of, contribution to fundamental advancing science. And I don't think most people outside of the narrow community were aware of that. But why not, Kai? Why are we not doing that communication better?
Well, think about it. Take another thing, which is not, is the fact that we now know from sequencing populations, vast genetics, that there are no differences between so-called races or ethnic groups. The difference between individuals are bigger. That's fantastic. All of us should know about that, but we are not getting it out to the public. And I think here we're doing a poor job. It's really clear. And I am feeling that when I go back to that, yes, everyone cannot do it, but there are too few to do it. That is the problem. And there are many who are good at it, and they don't. And I therefore wanted to stress that it's the institutes that have to do it, and those among the young and the older ones that want to take part do it. But every institute has to do this to reach out. And I think the only way, maybe EMBO, maybe one could think about programs that one can include when you give lectures for seniors or anyone else, Rotaries or whatever. That there is something that are points that you come up with ideas for communication. I think this is, Angus, as you are trying to stress here, extremely important point where we are not doing as well as we could. We have to do more. And space and physics does it because they are so costly that they have to do it. And now we are also costly. It has changed. We are using a lot of money. That's the biggest change in my lifetime.
So one other example, maybe again, I appreciate comments, and please do come on the chat. But I can make a confession that I end up watching quite a lot of YouTube channels and picking up information, and I can get also I'm very impressed at how many physicists, including young physicists, are motivated to set up YouTube channels and actually do public communication about particle physics and, how does relativity work? And there's a plethora of information, and some of it amazingly well done by individuals on YouTube. Now, please point out to me all the channels I'm missing, but I'm not saying there's nobody, but I don't see that equivalent activity coming from the biology community. And I just think there's room for more things we could do, and maybe we could help encourage people to do that, because I think as biologists, I'm passionate about biology, and I think we're just as passionate and enthusiastic and smart as some of the physicists and space scientists out there, but maybe we haven't engaged as much in seeing that as a valid, useful thing to do. I don't know. I really welcome feedback or comments about that. But Kai, can I just come back, because one of the ways where it's perhaps easier to explain to the general public, and certainly I think whenever I've spoken with the newspapers or TV reporters, they're always looking for an angle because they think the public are relatively stupid and want to be told what's it going to cure, what's the benefit, rather than just thinking knowledge is good for its own sake. But you're someone who's made a long, super successful career in basic science, and you've now launched a company. What's your experience of doing that, and how do you find the process of running a company and doing science in that world compared to academic research?
Okay, we're switching. I think it's so. I have, of course, been a scientist doing basic science all my life. I have a 60-year career, science. I started publishing in 1961 or something, and all the time I've also been thinking about where will this lead us and what's going on. I mean, I just go back to my early days at EMBL. We published in 1978 a paper for subunit vaccines against Semliki forest virus that kills mice by encephalitis. And we had the most fantastic subunit vaccines based on our research. And can you believe it? Novavax, one of their vaccine is not out yet, but the European Union has already ordered 100 million doses of their vaccine. It's exactly based on our work. And that was 1978 published. So there you are. I mean, we even had a discussion at EMBL when Lennart Philipsson came. Should we do some applied projects? I mean, something which you think about something important, and have one applied target. And I should say spoke for vaccines, and I find it amazing that there is the vaccine know-how in the world. I did not expect that it would go so fast, but it hasn't been on a very high level, because vaccines, as you see, it's lots of companies doing it. There is not much know-how for vaccine in the academic communities. Academic research was not part of it, and there you have it. I mean, it's fantastic that the startups that are coming out of research have the capabilities of doing what they are doing. And that's exactly what I felt. I mean, when I started this company, my company, of course, I had to look for something to do when I closed my lab. I was 75 then. I'm 82 now, so lipids, rafts, lipids, membranes, cell membranes. We had put up with Anna Zechenko a method for a platform for analyzing lipids. When you go to this hospital today, you have cholesterol, LDL or HDL, and triglycerides, but there are hundreds of other lipids, and those we can all analyze. So I then collected some people in my lab who didn't want to go to group leaderships. They joined me, and we are 20 people now, and it's a fantastic thing to what are we doing? Our slogan is lipidomics for a better life.
Well, certainly
for a better life. Well, at the moment we are having so we have seen that the blood lipidome reflects the metabolic status of what goes on in the body. I won't go try to explain why here now. But if you prick your finger, a blood drop on a piece of paper, a dried blood spot, so to say, there, send it in to us. This is an assay we are putting together. And then we do the lipidome of the blood. And that, what we want to put up is a health test. So wearables, the Apple and all the rest, they measure physical methods. But life is not only physics, it's chemistry. We need chemistry. And lipidomics is chemistry. So then the idea is you get the lipidome, and then you can navigate yourself towards health, away from health. That's our test. And so you see here, you go from your basic research, membranes, lipid rafts, lipids and proteins, lipid technology, you go into a company. And if you are in good shape, then you have a lot of experience when you then start a company, a startup, compared to someone at 25, biology, or 30 years. Biology is complex. You have a network, you have connections, and all that. So I think I am so happy doing what I'm doing, and I think it gives me some extra quality to my life.
Go on,
Sigrid,
Hang
your
on.
hand up.
Yeah, I want to ask Kai if he wants to collaborate on spaceflight samples. We have a whole biological repository of samples from space that could be analyzed for lipidomics, and if you make that data public, that would be pretty cool. So we could host all that data in our GeneLab database. There's both animal samples from a lot of experimental rodents and fruit flies. There's not so many fruit flies, but there's a lot of bacteria. There's Johnson Space Center has a lot of astronaut samples as well.
Oh yeah, I think the nice thing, the important thing for me putting up a company, if it would be a competitive area with many players, I wouldn't do it. But lipids, they disappeared in the DNA revolution, and now they're coming back, and there's little know-how, and therefore lipidomics is the last of the omics technologies that have come into play. So there we still are trying to attract interest with our products. It's working well enough, so otherwise we wouldn't be growing. But still, it's all in its infancy, and it seems like lipids are going to be a very important part of health and of measuring health. And
I think lipid rafts in space is we've just discovered something, Kai, for exciting the next generation. Lipid rafts in space is obviously the
that sounds very
Open to misinterpretation, I would say.
I'd like to also shout out to a comment that Nush has put in the chat. Again, reminding that in one of our previous discussions, we mooted the idea of the Alumni Association playing a role in setting up a YouTube channel and helping to do something towards this. So I think that's really worth doing, and this is a call for volunteers. So anyone who would be interested, and Maria, I think you should have your hand up and contribute, and Kaya and Sigrid as well. And perhaps there's an opportunity for an EMBL Alumni NASA collaboration here, Sigrid, if that would be a possibility. But I would encourage us to think seriously about this, and part of that is encouraging the people who participate in these meetings and have such good excitement and passion and enthusiasm. I think it's enthusiasm and passion that we need. Speaking of which, I'd like to ask Francis, who's got his hand up, to come in. Francis? May have to be unmuted.
We can't hear you.
Can you unmute Francis Peter?
Unmute. It's actually not Francis, but Francis' wife.
It's Shelley here.
Hi, Shelley.
Wonderful idea, and I'd be very happy to contribute. I think it's so great. My personal contribution would be to see if we can show some of the very inspiring photo micrographs and the wonderful images that have been developed over the years to show natural structures. And as I said earlier in chat, a lot of graphic depictions and things which are just visually so exciting that I think we could get a lot of enthusiasm and use those as a way of stimulating discussion and getting people interested in the topics of molecular and cell biology.
Yeah, I think that's a great idea. Fatima, would you like to contribute?
No, and just as I see people is leaving, I just wanted to reiterate my invitation from the beginning of the talk to join us next Friday at 4 p.m. usual time for the talk of alumni Florence Besse, which she will talk about a little bit about her scientific life, what she does now, which is related with RNA localization in neurons, and how she got there, how EMBL helped her, and also about career tips for people in France. Okay, so please join us.
Thank you very much. And Keith, were you wanting to come in again? You unmute.
Yes, thank you. I just wanted to make a heretical suggestion. Have you ever considered it might be a good idea to get people who don't understand the topic to present it to lay people? Because they know what everyone else doesn't understand, and they won't say something until they've understood it and can explain it.
Excellent, Keith. I've noted your name as one of the people to join this group.
I have absolutely nothing about it. I'm doing a very good job.
Good point.
Yeah, actually, I like that idea, and I thought in the past in things like I think some of the best like ski instructors are people who didn't learn when they were 2 years old, who can't remember what it's like not to know how to ski, but people who learned when they were older and can appreciate the difficulty of us older people who are having to learn. So actually appreciating the difficulties of someone in learning I think is a very valuable way of getting involved with this. I know the time is running quite short. I've fantastically enjoyed the discussion today. One thing I just wanted to pose to the speakers as well, and maybe to Kai or to anyone else in the audience who has been involved in translational research rather than just basic research. One thing I've experienced and been told by people is that many academics feel that if they leave academia, let's say after their PhD or their postdoc, or even as later in their career, and then go and work in a company, it's a one-way trip. And they're sort of discouraged from doing it because they feel if they go and spend 3 or 5 years working in industry, they'll never get back into academia again, should they choose to. Do you feel that's true, Maria, first of all, and then Kai? And is there anything we can do to make this less one way and make it easy to move in both directions? Because I can see great value in that.
So in the US, it is much more fluid, certainly between academia and industry. Here in Europe, even going from academia into industry at a high level is almost impossible. They bring up their people from inside. So I don't know why European industry is so conservative, and then conversely, I don't know why European academia is so conservative, because I mean there are few cases. Peter Goodfellow is a case, he sort of was in between for some time, but we don't have something like the big American places where it's perfectly normal to go back and forth. I don't know why, and the same is for other things. Even having babies and deciding to drop out 15 years. In the US, it's possible to come back. Here, there are examples here. Here, it's not so easy. Or doing something completely different, being a communicator. And then I observe this, and I have no idea why.
Could EMBO help with that in future? Is that something EMBO could take up as providing some sort of leadership or best practice positive example?
Well, we'd need the examples. Where are they? EMBL.
Well, you could find them.
EMBL could hire people who've been out of science for 15 years. EMBO doesn't do that.
Okay. Here I think you are now. I mean, this is not real. If you take the startup culture in the United States, that's why it's so lively. It's the startups who get big. I mean, there are lots of them. Genentech, if you are Genentech, you can do search still. I mean, in big companies, it's a big company, but it still was a startup, and it has the startup culture, part of it left. So that's the problem. In Europe, it's not such a strong presence of companies which are still flexible. And then one should know that, of course, it is not, it's hard work, and you have to learn a lot of new things. And then when you go back to science, then the question is that how long can you stay away? I mean, a year, no problem, but 2, 3 years?
It depends on the science. It depends on the science. But can I say something? I mean, yes, the startup is certainly part of the culture, but it's not only that. For instance, Mark Fishman, who was a researcher at MGH, I think, at Harvard, MIT Harvard, he became the director of research at Novartis. That is not a startup. Roche used to have Roche Nutley used to have a place in the US that was research. So it's not just that. There continues to be more fluidity. I mean, the startup culture is fantastic, and Genentech is one of the obvious examples. It's both. It's not done here.
Yeah,
of course.
I think
the academic career in the US is also more fluid. There's less job security. Here, I was a Beamta. I mean, I lived in a golden cage. I have guaranteed pension, guaranteed everything. So people don't leave that so easily. So I think it's part of the structure as well. It is more
Sigrid.
Yeah. So also in the U.S., there's a lot of government contracts for small businesses and even for startups. And so at NASA, there, at the institute where I work, there are several thousand employees, but most of them are actually government contractors. They're not actually civil servants. I'm one, there's maybe 10% civil servants or even less, and the rest are all contractors. So everything is done by contract work, and so the companies actually can get a lot of work, by applying for these government contracts that can be huge, absolutely huge. So that's why you have Elon Musk going to Mars and the moon. So there's a lot of incentive for companies actually to do scientific work, and those are the government actually pays for it.
Maybe can I add something here, Angus?
Yeah, sure.
So when I was pursuing my postdoc, I did my postdoc at a Max Planck Institute in Berlin, with Thomas Meyer and Kaufman Group, and then I was in EMBL, and then I was in the DKFZ. And during this period, what I've seen that the PhD student there in Germany, they somehow, get detached from the science, and they were mainly behind the money, because money is the main driving factor why everybody, try to join the industry. And these are the two reasons. One is the perseverance. Most of the people does not prevail the perseverance, because in science, it's a kind of pregnancy. You're very easy to conceive, but difficult to maintain. So you have to have a kind of driving force to maintain the placenta of the science, in your brain. And so from that point of view, I think, if you see the company, they go to the company frequently because they are secured, they get money, they get very good lavish package, and they have to work in the limited spectrum. So that is the main problem. And I think the one has to have a driving force right from the beginning that, if you can help in converting your science into some product, that is the point. But when to take that step in for the industry, for the translational research, that's a very important question. And I think one should be calculative. One should be calculative. When you are about to reach, when you are almost going to the validation platform, then you should switch. You can make the switch, and there's no harm and there's no problem in that.
Okay, thank you very much. We're pretty much out of time. I mean, 90 minutes has flown past really, really quickly. I'd like to also thank everyone who has already volunteered their help with our thoughts about future initiatives, and I'm sure Noosh will and the team will be in contact with you to follow up on this. Thanks to our speakers today, Sigrid, Kai, and Maria. And Maria, I'd like to give you the last word. And also to say personally, congratulations and thank you for all the work you've done for EMBO, which has been a fantastic service to the whole world community, not just the European community. And I'd like to invite you to have the last word today and perhaps to share with us your thoughts briefly about where EMBO will go in the future.
Well, I mean, where EMBO will go in the future is up to the next director. But I've got another year. And as you may know, two things that I started at EMBO. One is science policy. And what we talked about today is very important to in that context. So I think we will be doing more to address some of the problems that we already have done. But the ones that came up today, I think, are very interesting. And I think I would eventually like to, in the context of science communication, I would like to come back to this group because I've seen a lot. I didn't take notes, and people who posted in the chat didn't elaborate on their ideas, but also what you said about the physicists. So I think if I may exploit this group at some point to get further feedback. It's nice to see that everybody here feels that way about their science and about communicating and about also the basic science. Perhaps we're a selected bunch, and maybe this is not general, but I've learned a lot, and I'm grateful for that. And it just shows what a great community this is. So thanks for organizing it, guys. Coffee at EMBL. Thank you for organizing it, and it's a pleasure to be part of this community.
Thank you very much indeed, Maria, and thanks to everyone once again for taking part. Stay safe and have a great 2021 till we see you again. Thank you very much indeed.
Thank you.